Lung cancer classification using logistic regression Python program. And this program is written by referring this concept. So we need to implement all this expression which is addressed here. Equation 2, equation 3, equation 4, 5, 6, 7, and yeah, that's all. Okay, let's talk about this. So first, I have created functions: accuracy, normalize, and sigmoid. So the reason to use the normalize function and sigmoid we will talk about first. Sigmoid is essential because logistic regression concept, we are supposed to use this kernel or activation function named sigmoid. So this ensures that you when you compute the linear combination of the input signal with the weights or theta, you don't want the output to go above 1 or 2. You just restrict the value of x, make it lower, so that while computing sigmoid, it will ensure that the data which you are going to get will be restricted to 0 to 1. So sigmoid function ensures any data you feed z, when you give z as an input to sigmoid, so z might have a value, sometimes it might have a value more than 100. There is a chance, because when the data set is huge, when you compute the linear combination between the weight and input, it might grow a huge number. That number could be reduced, its amplitude could be brought down with the help of sigmoid. And the sigmoid over here is very much important, and this is to attenuate your amplitude. So it ensures at any cost your data will not be growing above 1, and it will not be lower than 0 also, so that you can use this for well for classification. And normalize to ensure that the data what you have, input data what you have, has to be in the limit, probably -1 to +1. So this code ensures that any data you feed, x might be having a value. In your case, age is that number which is very high. Age is in the range more than 40, and it is lower than 70. So that number cannot be given directly to the logistic regression model. It has to be scaled down, it has to be normalized. So normalized job is over here is to scale down the input features, so that later when you compute the linear combination between the input and the weights, the data doesn't exceed huge by huge fraction. And accuracy, we will talk this accuracy function when we are about to work with this. The packages required for running this: CSV file you require, numpy you require, and matplotlib you require. CSV to read your CSV file, numpy is the numerical Python package used for dealing or handling when you have a huge massive amount of data, to process it faster using the built-in functions like sum, dot. Those functions, when you apply it on data, so it will give you the answer within a fraction of second, rather than if you can even use your own user defined function to compute matrix multiplication or summing up a number in a list, but it takes time. So rather than that, you can use the built-in functions available in NumPy, which is far more efficient, effective, and with very much good speed also you can get the result. And the starting program, we have defined here variables a to x1. So the reason I have used here a to x1, a to y, this intermediate variables are used for holding your input data. So you can observe that this is your data which you're going to read, and this is having 309 rows, 310 rows, but we will exclude the first row which talks about the attribute. So this attributes are not important, and we are going to extract all this value. and we assume this gender, age, smoking as the keys. So we have a method, dictionary method present in the CSV library, which we can pick, and by giving the key values we can fetch the values present in that particular key. Okay, and here we have defined a to 0 variables are used for holding the values gender to chest pain, and for lung cancer attribute, this attribute we define a variable y, wherein all the information present in this file will go and get stored in this variable. So we have defined the dimension of this variables as 309 and 1. 309 row implies 309 rows and 1. So this is your column vector. And you look at, when you think this practically, A happens to be a column vector, B again is a column vector, C is a column vector. So all are column vectors. But x1, when you observe this x1, so the intention of defining x1 is to ensure that all the values, variables a to y, not excluding y, a to 0, I want this information to be fed onto a new variable x1. So x1 is your complete data set with all information. So the dimension of this should be 309, 15. Why 309? This because you have 309 information. When you observe, these elements are 309 in number. So the row size should be 309, and 15 because you have 15 features, 15 different features you have. But when you are processing further, you're supposed to add one extra feature, that is theta naught value will be multiplied with 1. So one more column you have to construct, wherein the values of this column should be made 1. Then you construct your x value or x feature. Okay, let's look at how it is created later. Now you have a x1 with features 309, 15, and all elements which you pass it from this file to this variable has to be transferred back into x1. Then we will process x1. Okay, and here you have the function or program to read the CSV file. So we will be using open function. Open function is used for handling your files. So here we are using a CSV file, and it is meant for reading. The mode is read. Give the file name and use R. R implies you can read, you cannot change the content. If you want to change the content, then you have to use read write RW mode. Okay, and this is your CSV file. So it creates so with open this as CSV file, then all this information present in this CSV file, uh, with the help of dictionary, so this is reading it as a dictionary reader, the content of CSV file has to be decomposed in such a way that whenever you encounter comma, it has to be ignored. Comma has to be ignored. All information what you have. So here you can observe there is no comma as such, but if you convert this into text file, then you can observe that there between two information you have a comma. So when you convert this into txt file, you can observe gender, there will be a comma, then you have age, then again comma, then smoking, comma, so on it goes. So comma I don't want, that is not my information, so I have to ignore it. For ignoring, you write with respect to what you will be ignoring. So here we will be ignoring the file content with respect to comma. So this is your delimiter. Ignore this comma information, and you create an object named as CSV reader. So this constructs one object from your dictionary, and this object has a key and a value pair. So using key you can access the value. So next what we do is, for this whole object line by line we will process. Think as if now CSV reader is all this bunch of object with no comma. Comma is ignored, and all this information you have. Now line by line you need to scan. Hence we use for lines in CSV reader. So this is your complete object. Read it line by line. So in the first line what you have? First line you have this information, and second line you have this information. Now you're in this region. So this is your first line. Okay, so this many information you have, and this n69 1 2 so on, this information should go and get stored in the variables reserved as a to 0. Okay, so you use here for lines in CSV reader B of I. First what it will do is based on lines first row lines of age. So now think as if this is your keys: gender, age, smoking, yellow, anxiety. So lines of age happens to be this component. This is your key, and this key is having a list of elements or list of values. So each one you need to grab line by line. So first line when you are in, and when you write lines of age, you're going to get 69, only 169 you get, and this has to go to a variable. And that's what is done by using the command if lines of gender, look for the key gender. This is your gender key, and the first row I mean this one second pointing to 2, this information m should go to the variable. In this case the variable is a. So there you write it as 1, because if the gender is m, we are considering it as 1, and if the gender is f, if not, if else, in the sense it will be f. You can have m or f in this gender column. So if it's f, then it is a female. So for female, for identification we use 0. Okay, similarly true we use identification 1, and for false we use identification 0. So y will have 1 and 0, only those information will be there in your y, and all other values you can get it in the corresponding variables. So all variables content a to o will have information about the keys which are gender to chest pain. So this all information will go and it get situated in the variables defined. So once you have all this data collected, now we create one common variable named as x1, and we store all those columns in a matrix form. So first column if it's a, what you have in a is A is defined down the line here. So A contains the gender information. So this information, gender information, MMFF, first column element should go and get situated in the first column of X. And that's what we are trying to do here. So here we create a X1, and its dimension is set to 309 rows, because 309 elements are there, but you have altogether 15 features. So 15 columns you need to build, and that's constructed using this command. After that, first column you place all the values what you have in gender, and second you place all values what you have in B, which is age. Okay, so you get x1, a matrix which has a data set information itself. So this is a common variable which you can access rather than accessing each of this variable. This is used for easing your application, so that parallel you can work on your algorithm. Then we define number of weights, that is the theta values, as 16. Theta value 16, that is number of features plus 1. So number of features you have, altogether you have 15 different features starting from gender to chest pain. And we use theta naught as, since theta naught will be added with theta 1 times x1, theta 2 times x2, so on, theta naught is multiplied with 1. So for that we create one column wherein all values are 1. So here, while defining, number of weights are 16, that is number of attributes plus 1, hence it is defined as 16. So first column ensure that you stuff 1, and the remaining columns, the values of x1 should go and it should get in x3. So x3 is a new variable created which will have first column 1, and the remaining rows and column will be exactly equal to what you have in x1. So that's what is x3. So it is built using this command. So the dimension for x3, first column, anyway we use numpy 1, so all values will be first 1, initialized to 1. First column don't change, the columns from 1 to 16 you have to change. 0th column keep it as it is. That's in Python. So it will look at because I goes from 0 to 309, and j also goes from 0 to 15. So this is I and j plus 1. So when you observe this, we have used j plus 1, not j, because first column don't change, so it goes directly to the second column, and there x1 information will be stopped. So you get x3, and this is your information. Now what you have to do next is you have to pass this x3 to a function normalize. So in this normalize function, the method what we follow is we compute. So suppose if you have you know values like column wise, this way you have numbers. So what you have to do is column by column you compute the mean, and column by column you compute the variance or standard deviation. Use this mean and standard deviation, and divide the input using this formula. So it takes x, it gets the row size and column size of x, then it creates a variable named mu, and also it creates a variable named sigma, which is a standard deviation. So the dimensions are 1 here, and so C implies the total number of columns. So you have 16 columns for your x, right? And this creates 16 by 1, so 16 rows and one column vector m view and m uh, sigma it will create. So what basically you are supposed to place in the first value is actually the mean of mu of I is equal to np dot mean. Compute the mean of the, when I substitute I as 0 here, first column mean it will calculate, and that will go to the first position. For example, let's assume you have 10, 20, 30 and 40. So first column 10, 20, 30, 40, you compute the mean of this. So that might be somewhere nearer to 20. I repeat, 10, 20, 30, 40, you have 4 values. Compute the mean of the first column. So you get nearly 20. Similarly, I is changing here. Also compute the mean of the second column. I goes here. Okay. Third column, fourth column. So altogether you have now 16 means for all attributes starting from first column you have all 1 definitely, because x we made it 1. Then x second column you have the gender information, which is 0 to 1, so you have to compute its mean. Then you have next age, which is in between 40 to 70, compute its again mean. So 3 means we have calculated. Similarly, compute 16 means. Similarly, use the standard deviation, compute the standard deviation also. You know the formula for evaluating standard deviation, it is x minus x bar, where x bar is the mean, x is your input, divided by total number of features, total number of elements, that is 309 values you have in this case, and it has to be summed. Okay, all elements you have to sum it up, that gives you the standard deviation. Once you evaluate that number, then apply this formula to get the normalized data. So normalized data is equal to the input data minus the mean divided by standard deviation. So when you use this formula, this does it for whole data set. For whole data set, information will be stick between -1 to +1 in this case, so that you can apply it directly for logistic classification model. So that's what the normalization does, and the normalization gives you this input. After that, we are supposed to create a value x, and this x is created for 309 rows and 16 columns. So this is this has to be passed on to the value. X2 value is passed on to this. The first element is kept 1 itself, and the this you can even ignore this step. I've done it. You can just try to ignore this and see what happens. Directly take x2, no problem. So here it is ensured that all elements are normalized, but the first column I have not normalized it. First column is kept 1 itself. The remaining elements I have normalized. Okay, so it might give you a number which might be nearer to 1 first column, but you can ignore it. Then this is your logistic regression formula. So what you have to do first, initialize all weights thetas to 0. So here we use that step. So initialize the theta weights to 0. So how many values of theta you are expecting? You are expecting 16 values of theta. Why 16? Because you have 16 features. So thetas will be theta naught, theta 1 to theta 15, as you have here. Okay, so as you have this information, it should be theta 0. So you have theta 0, and even just remember, even this should also be theta to 15. So just change, if it's not done, this should be made 15. My mistake, should be made 50, 50. 0 to 15, so you have 16 values. So this many values of theta you have. Then use equation 3 to estimate theta times theta to x. Okay, and obtain the hypothesis from equation 2. Okay, so first you evaluate theta transpose x. So what is theta transpose x? Theta transpose x is computed using one line code. Theta is equal to, after that, so we just define this. So this is actually the loop, and we have defined the learning rate as 0.01, 0.09. This is your alpha value, and gradient, the dimension of gradient will be, gradient is dou theta naught by dou j, dou theta 1 by dou j, dou theta 2 by dou j, so on. We are trying to find when the cost changes by a small amount, how it affects the how the weights like theta naught, theta 1 to theta 15, when you change it by small factor, how that is going to change your cost. That is what the gradient exactly means. Okay, and here the dimension is exactly equal to your theta dimension, because those many numbers of gradients you'll be getting, dou theta naught by dou j, so on. Okay, so first you have the range. This has to be repeated. How many times you need to repeat the iteration? So 2000 times over here the program repeats. So first theta is fitted as initial of theta, then you compute the value, that is h theta into, theta transpose x. Okay, theta transpose x, what is theta transpose? Theta is your theta transpose. So theta dimension is, it is a column vector with the elements you can observe here, 16 comma 1. 16 comma 1 is your matrix. Then you have one more x. So what is the dimension of x? The dimension of x is 309 comma 16. So 309 comma 16, and you have 16 comma 1. So you can compute the matrix multiplication. Okay, so 309 is a matrix, and you have 16 by 1 vector. Okay, so first row, first column you can multiply, you get one number. Second row, first column you can multiply, you get one more number. So altogether the dimension of this h will be exactly equal to 16 rows, one column. Okay, I repeat, the dimension of h will be 16 rows, one column. So you'll get this as the information. Then this number might go beyond 1. So what we do is we apply it to a sigmoid function. Okay, we compute the sigmoid of h by using 1 over 1 plus e to the power minus theta transpose x. That's the formula. Then we take its log. Why log? That's basically we are using here logistic regression. So log function is used with sigmoid. So sigmoid function gives you a number value between 0 to 1, and apply log onto it, and this number is g1. Why that is required? When you observe this equation, you are supposed to find the product of the predicted value. The predicted value is log of h theta, and y is your expected answer. This is your desired data, and this is your predicted data. So predicted data is log of h theta. What is h theta? H theta is 1 over 1 plus e to the power minus theta. So first find theta transpose x, then get h, then apply it on to log, and that's what is done by using this command. So you compute g, which is log of h. Okay, log of h, log of sigmoid of h. Okay, fine. So then again you compute g1, which is the second term. This is the second term. So you have 1 minus log of h. Okay, so h is this is implemented. Then we multiply this. When we find the dot product of this, then we divide it by a number 1 by m. Then we have to put minus negative sign. So add all elements, then divide it, scaled it down by 1 by m, then multiply it by minus m. That's what is happening when you observe here. Temp1 is your first quantity. Okay, temp1 is your first quantity, that is this term. Summation I is equal to 1 to m yi log of h theta xi, that's your temp1. So you can observe this Okay, temp1 dot product of y and g, so you can compute the dot product, and you have to transpose it because the dimension of y and g are matching, and you expect this to be a one number. So this is having a dimension 16 by 1, this is also having a dimension 16 by 1, so you cannot compute the matrix multiplication of this two, so you have to transpose it first. So you get now 1 by 16, you get a row vector, you get a column vector, then you can compute the matrix multiplication, so in turn you get a number here. Similarly, this also is going to give you a number, so ultimately the cost is a number. Okay, I repeat, the cost is a number because this gives you one single quantity, this gives you a single quantity. Once you compute the cost, place the cost in the variable cost, which is a empty list. So append it as soon as you create get one cost value, append it, so that if you want to plot the graph, cost graph, you can do it by using the plot function. Okay, so that's what the program does now, right now. And finally, after this, append it, then compute the h function now as sigmoid of yeah, h, this is already there, this is already there. So but we use this h here to ensure that the dimension of the h value is always 1, column dimension is always 1, that's why we are going to reshape it. So you can use this h itself, but this one, when you evaluate, you can figure out the dimension of this h, its dimension will not be 16 comma 1, it will be different, but we want that to be 16 comma 1. So this means reshape negative minus 1 means the first argument, how many number of elements you have, those many number of rows it will create, and the column will be fixed to 1, that's what we expect. So this will give you 16 comma 1 dimension h at any cost, and that is what is expected, that's why we reshape it, we redesign it. The next statement is compute the gradient. To compute the gradient, we will be using this formula. Gradient formula, this is the formula to compute the gradients. So dou j theta by dou theta naught is equal to 1 by m h minus y. Compute, find the difference between element wise, you find the difference, sum it up over the range 1 to m, that's what has to be done, then divide it by m. So that's how you compute the gradient. So you have h now, you have a predicted value, you have the output value, then compute the sum. And the same is true over here. Here you can write it as 1, no problem, because for theta naught this is 1. Okay, and can observe one line command we will be using to implement it, this equation. So x compute its transpose, x dot t implies compute the transpose of x. X will be now it will be transposed matrix. So what is the dimension of x? X was having dimension 309 rows and 16 columns, now it becomes 16 rows and 309 columns, then h minus theta. So this anyway is having 309 elements, 309 elements and one column. So you can directly multiply, you can compute the matrix multiplication of this number, and in turn you will be getting the dimension as 16 by 1. The dimension will be 16 by 1 because the value of x transpose is 16 cross 309, and the dimension of this one h is h or y is 16 cross 1, 309 this is 16 cross 1. So you expect the answer to be h will be 16 by 1 matrix, and that is what is expected. Then flatten, because here if the dimension doesn't match, so flatten it to ensure that you get 16 by 1 dimension. That's what the answer is. And finally re-evaluate the theta by using the formula theta is equal to initial theta minus transpose of gradient alpha minus. So what is this? The reason why you are using this is to ensure that you fulfill this requirement, that is use gradient descent method and find theta j is equal to theta j minus alpha times dou j by dou theta j. So dou j by dou theta j is evaluated here gradient is that dou j by dou theta j. After that, use this formula and re-evaluate the value of theta. After finding theta, then initialize theta will be equal to this theta value. This is the value of theta, but it has to be transposed. Otherwise, the matrix dimension will be mismatched. So ensure that don't go wrong while you're implementing this. So this is your program which you have to concentrate, which computes the gradients as well as it computes the cost, and also it prints the cost after 2000 iteration. It is going to print the cost. Okay, and after that you are going to get the answer, number of iterations, cost function. You get a graph, you can observe the graph, and can also find out what the cost function is. After that, you once you get the best values of theta, which will be there in the variable theta now, initial theta or even theta, then using that theta, compute the linear combination of theta with x, and apply it to the sigmoid function and check whether you are getting a value greater than zero point 0.5 or lower than zero point 0.5. For this feature, suppose if you are getting the value of sigmoid function applied on this greater than zero point 0.5, then you make the you say that this belongs to class 1. If the value comes out to be lower than zero point 0.5, you say that it becomes negative, it becomes to 0 class. It is to 0 class. 1 implies has lung cancer, 0 implies it doesn't have lung cancer. So then theta 1 will be the feature which will have this theta value. Okay, and then we compute the mean and we compute the standard deviation. So the mean is the mean of this mean is equal to the mean which we had in this normalize. This normalized function is going to give you mu and sigma value, and this feature is used here for processing. Okay, so whatever you get mu value and whatever sigma value you get, those are used here for subtracting the theta, this value of x. Okay, so you can find here the text data xt is subtracted with the mean, and also it is subtracted with the standard deviation. So the first element is picked here. Xt of I minus mu1 of I. So with all elements it's subtracting, so that's okay, no problem. It has to be done. Then yeah, xt minus mui. So this gives you the new value or normalized value of xt. It ensures that this DEV is having the dimension lower than between -1 to +1. Okay, that's what it is. So this is to ensure that you fetch the mu value, use that mean value and standard deviation, and normalize your text data by subtracting it from the mean and standard deviation. So this normalized data we expect here, then apply it onto the sigmoid function, find the dot product of the normalized data with the theta, and this number will be strictly between 0 to 1. So if it's higher than 0.5, you bring it in the favor of lung cancer. If it comes out to be lower than 0.5, you make it in favor of class 0. Then you get the predicted data what you get. This gives you the probability. Based on the probability, you need to figure whether it is class 1 or class 2. Okay, after that we pass this information to accuracy method, and accuracy method is going to determine the accuracy of this model. So from theta values, so this is your input, this is your best theta value after 2000 iteration. Use this theta value and go to accuracy function. So this theta value is taken, and your x you have here, this x is not normalized value. Okay, because here we are using x3. When you observe, x3 is not normalized one. X3 is this data. X3 is not normalized. So x3 was the data which was not normalized first. So take this data And here again you have to normalize. For normalizing you will be using this formula. Okay, so this function requires mean, standard deviation with the dimension 16 by 1 and 16 by 1, and it has to be subtracted with your input, which is not normalized data, and you have to compute the normalized data, which is the deviated data from input. After that you find this deviated data with respect to deviated data, with the weights which you get, compute y1, which is your predicted result, which will give you the probability. Okay, so for making the probability, or making which to favor which class, you take this probability, which is your predicted output, then apply it, define positive class and negative class. Suppose if p1 of y1 of I is greater than zero point 0.5, you make it 1, and positive class will be equal to positive class plus 1. Suppose if y1 of n is zero point 0.5, then you make it as 0. Y of okay, so what is this? If y of I is equal to 1, y of I, if he is having lung cancer, if y1 of I is also greater than zero point 0.5, then you are correct. Suppose if y1 of I is less than zero point 0.5 and y of I is equal to 0, then it is a negative class. Else positive class sticks as it is, negative class retains as it is, because there is a chance that sometimes you may get false detection. Okay, that is y1 of I might be lower than zero point 0.5, the predicted might be less than zero point 0.5, but you expect it to belong into class 1, that is false. So there you should not increment, so accuracy will be down in that case. Hence, if this two possible condition doesn't match, then don't change positive class or negative class. Then compute the accuracy as positive class plus negative class divided by m. Then return this information, and that's the program. Okay, so I'll run the program. So you get this as your answer: logistic regression without optimization, x label, have a cost function defined, and this is your cost value. After 2000 iteration we get 0.1528 as the answer. You can close this dialog box, close this figure, you will get the accuracy. This is your accuracy. Okay, accuracy is 0.994% is your accuracy. That's what you have. And if you want this information to go, you can just put a print state here in the accuracy program. You can just comment this point and you can rerun, so that clearly you can figure out the accuracy again. Okay, I'll close this. You'll get accuracy is equal to 94%. So this is your program. So I've also created one more program. You can try to run that also. So this is logistic regression SDMIT. So this program, what I've done, I have broken the whole program into testing phase and training phase. So testing phase, I have created altogether 50 samples, and for training phase I have created nearly 250 samples. So I've broken it, and this program will also give you the result. And when you run this program, you can figure out the accuracy is 100%. Accuracy is 100% for training phase, 100%. Even for testing phase, the accuracy is 100%. So even this program also you can explain. Okay, so all information whatever is required, I'll just mail you back. Thanks for watching the video.